Hi, so we continue now with the steps on the hypothesis testing. So in this video, we are now in the step number 3, and the focus of step number 3 is to compute the test statistic. Now again, take note that in some references, the decision rule could be part of step number 3. But again, the numbering is not really important, but what is important is to include all the steps in performing the hypothesis testing. If in one reference the decision rule is in step number 3, then there should be no problem with that. In the previous step, and that is on step number 2, we learned the different formulas in finding the test statistic. Now, the test statistic will depend on the information about the population standard deviation and the sample size. Again, if the population standard deviation is known, then we simply use the z test statistic, and it will have a formula of x bar minus mu sub 0, the hypothesized mean, divided by the population standard deviation over the square root of n. Now in the case that the population standard deviation is not known, but the sample size is higher than or equal to 30, we can still make use of the z, but we have to replace the population standard deviation by the sample standard deviation. However, if the population standard deviation is not known, and at the same time the sample size is less than 30, then we can no longer use the z, and that is when we use the t-test. And then we also learned how to set the decision rule, and the decision rule will depend first on what type of test you're going to perform. If it's a two-sided z or t-test, that means we only reject the null hypothesis if the test statistic, the value that you obtain when you compute using these formulas, is less than the negative z of alpha over 2, or if the z, the test statistic, is greater than z of alpha over 2. Now the same reasoning for t, and that means we change the z into t. So when t is less than the negative of t of alpha over 2, or the t is greater than t of alpha over 2, then the conclusion or the decision is to reject the HO. In other words, the z that you have computed will be on the area of rejection. It could be on the right, or it could be on the left, depending on the value. But if these values will be inside the area of rejection, then the conclusion must be to reject the null hypothesis. But if the value will fall outside the critical regions or the area of rejection, then the decision is fail to reject the null hypothesis HO. In the case of the one-sided test, if it's on the left side, if the critical region is on the left, then that means we reject the HO if the test statistic is less than the z of alpha, or less than the negative, rather, to be exact, it's the negative of the z of alpha or the t of alpha. Again, this means that the z that you have computed will be in the area of rejection if the z is less than the negative z of alpha, and that is why we have to reject the null hypothesis HO. In the same way, if we have a right-sided test, that means the critical region or the rejection region is on the right side, we reject the null hypothesis H sub 0 if the test statistic is greater than the z of alpha or the t of alpha, depending on the test. So in notation, this means the test statistic z is greater than z of alpha, or the t is greater than t of alpha. And if that is the case, we have to reject the HO. Otherwise, we say we fail to reject the null hypothesis HO. So let us take this as an example. Suppose that in a given study, the null hypothesis is mu is equal to 7 and the alternative hypothesis is mu not equal to 7. Suppose that the significance level set in this study is 1% and 50 respondents were surveyed and it resulted into a sample mean equals 6.38 and a standard deviation for that x to be 1.25. Now, since the sample size, or rather the population standard deviation is not given in this study, and that the sample size is equal to 50, which is greater than 30, then that means the test that we have to perform is the z-test. So we will be getting the z-test statistic formula, x bar, which is the sample mean, minus mu sub 0, the hypothesized mean, which is equal to 7, over the sample standard deviation over the square root of n. Now, supplying the numbers, 6.38, that is our x bar, minus mu sub 0, which is the hypothesized mean, 7, divided by the quantity or the quotient of 1.25, that is our s, divided by the square root of the sample size, 50. These values were assumed to be obtained from the survey that was done on this study. So when we compute for the exact value of this expression, you will get a negative 3.5072, which is approximately negative 3.51. Now, since the series of videos that I have been creating is for you to understand the steps in performing the hypothesis testing, I'll try to limit first the discussion on the use of the z-test. Now, in using the t-test statistic formula, for you to learn how to apply that, I will reserve a video by using a specific example on when to use the t-test. But for now, what is important is for you to know how to supply the formulas with the corresponding numbers that you have obtained when you gather the data. Or if these values are already given, then you should know how to use these values in the formula for the test statistic. Now, in the case that the study is about one population proportion, take note that the z-test statistic will have a different formula. And the formula for the z, if it is a one population proportion, is the p hat minus the p sub 0. The p hat is the sample proportion. So this is our sample proportion. P hat is equal to x over n. And then the p sub 0 is the same as the hypothesized mean. So this is our hypothesized proportion, divided by the square root of p sub 0 q sub 0 over the n, which is the sample size. Unlike the population mean, the test for one population proportion will not have a t-test formula, since the studies on proportion always require a large sample size. Therefore, the z-test should be applied. Okay, so let us take this as an example for the proportion. Let's say that the topic is the proportion of students in a certain school who go to a coffee shop for at least once a week. And suppose that the status quo, or what is being observed, is that at least 60% of the students go to a coffee shop. So that means this will be our null hypothesis. Now let's note that the population proportion is denoted as P. So H sub 0, or the null hypothesis, is P greater than or equal to 0.60. The hypothesis that is challenging this null hypothesis is that we might feel that it's not really at least 60%, but it could be lower than 60%. So the alternative hypothesis for the proportion is that the proportion is less than 60%, or 0.60. So note how I set, or how the symbols follow the rule on what contains the equal sign. So again, the HO will always contain the equal sign, while the alternative hypothesis H1 will not have the equal sign. Now, to gather data and to do a study on this, suppose that the significance level set in the study is 5% and that the group or the researcher who wants to test the claim that it is now less than 0.60 is to conduct a survey for 50 respondents. And let's say on that survey, 28 said that they go to the coffee shop or they go to a coffee shop for at least once a week. So with this information, we should already know that the sample proportion p hat, which is x over n, so 28 over 50 is equal to 0.56. Now, since this is a study on proportion, there is only one type of test that we can apply, and that is the z-test for one population proportion, and the test statistic z for this test is computed by having p hat minus the p sub 0, the hypothesized proportion, over the square root of p sub 0 q sub 0 over n. With the z-test, we need to note what type of z-test are we going to apply. Is it a one-sided or a two-sided z-test? Again, to know which is the correct type, we have to go back to the alternative hypothesis. The alternative hypothesis will tell us whether it's a two-sided or a one-sided z-test. Now, since the alternative hypothesis says p, the proportion, is less than 0.60, then this is a case of a z-test, or a one-sided z-test. And the side in particular that we want to consider is that of the type in which the critical region is on the left. Again, how do we know? Because the P, the H1, says that the P is less than 0.60. A less than null hypothesis will direct us into, or will lead us into, a left-sided diagram. Now, since this is just a one-sided z-test, that means the alpha is concentrated on the left. So this red area here is the alpha. And since the alpha set in this study is 5%, that means this red region has an area of 0.05. And with that, we need to know the boundary of that area, and that will be our z of alpha, or the negative z of alpha, which is the negative z of 0.05. Then we make use of that reference in where we can get the z of 0.05. So the z of 0.05 is 1.645. Now, since the z of alpha is on the left side, then we should be using the negative value of 1.645. So the boundary is at negative 1.645. So when we compute for the z value, if that number will be on this critical region or the rejection region, then the decision rule is reject HO if the z is less than z of, or negative z of, alpha. Otherwise, we say, otherwise we fail to reject HO. Okay? And once we are done with step number 1 and step number 2, let us now see how we apply step number 3. So step number 3 is the computation of the test statistic z. Again, the formula that we are using here is z is p hat minus p sub 0 over the square root of p sub 0 q sub 0 over n. So what we will just do is to get the corresponding values and place them in the formula. So in the calculation, the p hat is 0.56. We have 0.56 minus p sub 0, which is the hypothesized value. It's a value set in the null hypothesis, and that is 0.60, divided by the square root of p sub 0 is 0.60. Now q sub 0 is the 1 minus p sub 0, and that is basically 0.40. Then divided by n, we ask 50 people for this study, so the n is equal to 50. And then all you have to do is to get your calculator and compute for the exact value. So the value that I obtained is negative 0.57735 or 4, or we can even say that this is 0.58. So that's how we perform the step number 3. We simply supply the formula with the corresponding values that we have in the information. Now the next step after this will be step number 4, and that will be covered in another video. So again, in step number 1, that's writing of the null and alternative hypothesis. Step number 2, that is where you set the significance level. That is where you set the decision rule. That is where you determine the type of test that you're going to perform. And then step number 3, which is the focus of this video, is on how to compute for the test statistic.